After we define what a rigid body is, let us define the rotational motion of a rigid body. The rigid body is that in which any two points distance of separation remains unchanged for all conditions. When the rigid body moves, the motion of the rigid body, let us take the example of this pen. If I assume that this is a rigid body because under considerable force I cannot compress it significantly. When I pull it with a considerable force, I cannot extend it or elongate it considerably. If I twist by a significant torque, I cannot twist it significantly. In that sense, let me assume that this is a rigid object. If I leave the rigid object, it moves like this. It's not changing its line of orientation. It's not changing its line of orientation. The line of orientation is this, and this is the horizontal. The angle between this pen or the rigid body and the horizontal is called angle of inclination. The angle of inclination is not changing. Then we can say that it is not at all rotating. And if you do like this, you twist it, you give an initial twist so that it keeps on changing its angle of orientation, and it is a clear-cut case of rotation of the rigid body. For rotation, you should not think that always one point of the rigid body should be fixed. This is also the rotation because its line was like this and its line of orientation or line of inclination keeps on changing. This is also a type of rotation of the rigid body. A rigid body rotates only when any line you are drawing inside the rigid body changes its angle of inclination. The angle of inclination changes, then you can say that the rigid body is rotating. That's what we are going to interpret mathematically. You take a rigid body, you take 2 points inside the rigid body, join these 2 points. You take a reference line which is fixed. Let it be x dash. With respect to the reference line, this line joining these 2 points inside the rigid body makes an angle, certain angle, say this angle is phi. This is the angle of inclination of the line AB. The straight line drawn inside the rigid body makes an angle phi with respect to this reference line. This reference line is fixed. And if this line rotates, this phi will change. For instance, this body goes to this position and this line AB now makes an angle, suppose beta. So, angle of orientation of the same line drawn inside the rigid body changes from say theta to beta. Instead of phi you can take theta also. Theta is the angle of inclination, say. Angle of inclination of AB at time t equal to t1. This is the initial position. At time t equal to t2, this is the final position. Of the rigid body. Since theta is not equal to beta, the rigid body is said to be rotating. The rigid body is said to be in rotation, or we can call it angular motion. Since this angle of inclination is changing, we can also call it angular motion or angular motion. So, rotation can be called angular motion. So, whenever any straight line drawn inside the rigid body changes its angle or changes the angle of its inclination or orientation with respect to or relative to any fixed reference line, we can say that the body or rigid body is rotating. This is the definition of rigid body. Whenever any straight line drawn inside the rigid body changes its angle of orientation or inclination from theta to beta in this diagram, we say that the rigid body is under rotation. So, this is the final position of the rigid body. This is the initial position. The shaded diagram is the final position. The plane diagram is the initial position of the rigid body. This itself is the rigid body. So, with this concept, I can tell you the meaning of angular velocity.